What about Tesla's cars makes them so successful? Design or technology? If you answered the latter, well, it means you're right. And as Elon Musk recently unveiled Tesla's new crazy motor, we'll explore why Tesla's EVs dominate the industry with it. The history of electric propulsion electric cars or EVs dates back to the mid-19th century, when electricity was one of the most popular means of driving cars, providing a level of comfort and ease of operation. Let's reflect back a little on the history of electric motors. In 1827, Hungarian priest Anyos Jedlik created the first unusual but functional electric motor, complete with stator, rotor, and commutator. The following year, he used it to drive a small car. Professor Sibrandus Strating of the University of Groningen in the Netherlands built the small electric car in 1835. Robert Anderson of Scotland invented the first crude electric motor simultaneously, powered by basic rechargeable cells, between 1832 and 1839. The exact year is uncertain. In the early 1900s, the first mass-produced electric cars came to the United States. The Studebaker Automobile Company started in the automotive business in electric vehicles in 1902, but in 1904 it expanded to the patrol car market. However, after the Ford Motor Company introduced the low-cost assembly line cars, the popularity of electric cars declined sharply. Electric vehicles did not gain much popularity at that time due to the limitations of storage batteries. However, electric trains have gained much popularity due to their economy and potential speed. Thanks to the advances in the construction of electric trains, the movement of electric trains became ubiquitous in the 20th century. Platform trucks, forklift trucks, ambulances, tow trucks, and urban delivery vehicles such as the British Milk Float gradually changed their general-purpose use. For much of the 20th century, the UK was heavily used worldwide for electric streetcars. The noise of electric cars has decreased due to a number of factors. Road infrastructure development required a longer distance than electric vehicles, and the discovery of large petrol stations in Texas, Oklahoma, and California has led to the widespread availability of fuel, making internal combustion engines less expensive to operate. Long distances. Internal combustion engines became easier to operate thanks to the invention of Charles Kettering in 1912, which eliminated the need for a hand crank to start the fuel engine, and the noise emanating from ICE vehicles became more tolerable due to the use of mufflers founded by Hiram Percy Maxim in 1897. As the highways outside the cities evolved, the range of electric vehicles could not compete with the ICE. Finally, Henry Ford's introduction of mass-produced petrol cars in 1913 reduced the cost of gasoline vehicles significantly compared to electric vehicles. So how do these stable and advanced motorcycles work? Direct current, or DC, is the one that flows in and out of each battery, positive and negative poles. Engines, as mentioned earlier, require a constant flow of power to rotate. The electromagnetic force may lock its north and south poles if they are not present. The motor is kept rotating in a constant rotation north and south. AC power is the most effective way to transport usable long-distance energy from an abundant source such as a dam or wind turbine. This is because fluctuating AC signal allows voltage to rise or fall to varying degrees easily. This is why your home stores are 120 volts AC, which are safe for human use. Yet the electrical power of a distribution transformer, those gray cylindrical boxes you see on power poles, can be as high as 65 voltage amp or 66,000 volts AC. Because AC power allows us to build more efficient generators, engines, and distribution systems from electricity than direct current, it is the most preferred current to power cars. Electric cars are starting to arrive and maybe even hit gas counterparts as technology advances. Although there's still a long way to go for electric vehicles, the development that businesses such as Tesla and Toyota have achieved so far has given hope that transport will no longer depend on fossil fuels in the future. At this point, we all know Tesla's success in the field, with the Tesla Model S sedan capable of traveling 288 miles, hitting 155 miles per hour, and producing 687 pound-feet of torque. According to the EPA, Tesla's uniqueness, Tesla, the latest S Long Range Plus model, has a range of 402 miles. That is an 87-mile stretch since the 100 kilowatt-hour car version was released in 2016. Tesla does this in part by producing its own engine, inverter, battery pack, and other components rather than relying on a Tier 1 source. Tesla can always change those components to improve their efficiency as a result of this customization process. The battery is at the heart of the system. Unlike other car manufacturers such as Audi, Toyota, and Mercedes, Tesla allows drivers to use the entire battery capacity. In the case of the Model S, this means that all 100 kilowatt-hour is available to the owner. rather than keeping a certain amount set aside for battery life. According to a Tesla engineer, the business has been installing the entire battery in all its vehicles. Batteries have limited lifespan, and some car manufacturers have agreed that if part of the cell fails, the backups will be ready for replacement. Tesla has informed Car and Driver that the new Model S will offer a much faster, less surprising charge. The current Supercharger V3 provides a maximum of 250 kilowatt and is compatible with Model S, Model X, and choose a variant of Model 3. So the V4 Supercharger or V3 upgrade will provide faster charging. Expect a support level of more than 250 kilowatt in the Model S and finally other Tesla vehicles. All of this points to a car manufacturer that seems to lag behind ordinary car manufacturers as they seek a more significant industry. However, the challenge of reducing costs still exists.